بسم الله الرحمن الرحیم. سلام عرض میکنم خدمت دانشجویان عزیز. امیدوارم که حال همگی خوب باشه. خب ببینیم که مترجم ما هست یا نه. توی کلاس شما هم مترجم داشتیم دیگه، نه؟ ماشاءالله کلاساتون زیاده و یک کلاس میگه که مترجم نمیخوایم و به همین انگلیسی ادامه بده کلاسو. یک کلاس دیگه میگه که حتما مترجم داشته باشیم، فارسی به عربی انجام بده. و نمیدونم حالا کلاس شما چطوری بود برنامه؟ خب به من بگید برنامه چیه؟ باید فارسی بریم، انگلیسی بریم، چیکار کنیم توی کلاس شما؟ کدوم یکی از دانشجوها فارسی رو خوب متوجه میشه که بخواد ترجمه بکنه به عربی برای بقیه دوستان؟ توی اون کلاس دیگه یه شخص به اسم آقای عقیل ابراهیم بود که فارسی رو خیلی خوب متوجه میشد و ترجمه میکرد. اینجا مگه یه نفر باشه که فارسی رو متوجه بشه؟ نه، اگه انگلیسی باشه که همون انگلیسی رو ادامه میدیم دیگه، احتیاج به ترجمه نداری که. دیگه متوجه میشن بچه ها. خب اجازه بدید ببینم که برای فایل رو باید تغییر بدیم. نه، انگلیسی به عربی به نظرم نیازی نیست دیگه، همون انگلیسی رو پس ادامه میدیم و شما هم اگر توجه بکنید میتونید متوجه بشید. سعی میکنم که شمرده صحبت بکنم. بذارید فایل رو پیدا کنم من. Is there any student who can understand Farsi? I need one student who can understand Farsi. Mrs. Zainab, your Farsi seems to be good. Okay, no problem. I will continue in English. We can say in English, so I think there is not need to translate. I try to speak slowly so you can understand me completely. Don't worry about it. And let me see, where were we? Did we talk about real-time system last session? Yes, okay. And how about distributed real-time systems? Well, and cloud computing? Yes. Yes. Parallel computing? Yes. Okay. And about differences between parallel computing and distributed system? Yes. Goals of distributed system and transparency? No. Okay. So, yeah, we were here. We were here in this slide, distributed system and parallel computing, and I suppose I asked you a question last session, at the end of the session, and that was, can we assume parallel computing as a part of distributed systems? I mean, is parallel computing the same as distributed system, or we can assume it as a distributed system? Did you think about it? What's your reason? Why do you think so? I asked, do you think the parallel computing and distributed system uh, are the same? I mean, do you think, is there any difference between parallel systems and distributed systems? Or you can assume they are as the same system? So look at this picture. If you want to compare distributed systems or distributed computing with other systems, it's a good idea to go back to the definition. Think about distributed systems. What is distributed system? Can you remember the definition of distributed system? May you define distributed systems? I told you it's very important to memorize it. A computer environment. It is a definition, but this is not our definition. We use another definition, so please do not copy paste from internet. What was our definition about distributed systems? Okay, you forgot. So let me back to the to this slide here. As you can see, please memorize this definition. It's very important. A distributed system is a collection of independent computers or machines that appears to its users as a single coherent system. What does it mean, coherent? Do you know the meaning of coherent? What does it mean, coherent? We have a very beautiful word in Arabic. مستقل. مستقل is independent, but coherent means منسجم. منسجم. Do you know? Yes, منسجم. It means the users see the distributed system as a whole system, as a single coherent system. So it is the definition for distributed system. Now compare this definition and parallel computing or parallel systems. Does the parallel system satisfy this definition? What do we have in parallel computing? What do we have in parallel computing? Yes, we have many computing machines. We have many computing machines in parallel computing. They can be assumed as independent machines. Yes, because each machine calculates its problem, runs its program, runs its task, indeed. And we have a collection of these machines. In distributed system, we have a network to connect computers together. Do you think if we have a network in supercomputer, do you think if we have a network in a supercomputer too? Yes, yes, we have too many processors in a supercomputer connected together. We need to connect these computing machines together. If you look at this picture, you can see these cabinets are connected through a network. So in this system, we also have a network. And the last part of the definition says that the user in distributed system, users must see the system as a single coherent system. What about distributed computing? I'm talking about the last part of distributed system definition. It's about single coherent system, and it says that users must see the system as a single coherent system and compare it with parallel computing. If a user works with a supercomputer, what do you think? If he sees if he sees the supercomputer as a single coherent system? Yes, exactly. When a user wants to solve a big problem and he works with a supercomputer, okay, he has a one problem and one program. He starts the execution of the program in supercomputer, and he thinks he is working with one single system, not a distributed system, not a collection of so many processors. So supercomputer can satisfy this definition. However, there are some differences too. We talked about similarities, but there are some differences too. Look at this picture. Distributed computing, as you can see, contains many processors and their dedicated memory. In distributed computing, we use different independent computers. Each computer has its processor and its memory. So the memory is distributed in this system. But in parallel computing, we usually, not always, we usually use a shared memory for all processors. I repeat it again. In parallel computing, we usually, and not always, we usually use a shared memory for all processors. This is the big difference between parallel computing and distributed system. But however, we have some similarities. we talked about similarities. So some people assume that parallel computing and parallel systems are a type of distributed systems. Some others think no, they are different, completely different. But to me, it's not completely different. There are some similarities and some differences. And I think we can assume that parallel computing is a type of distributed system. Clear? Mr. Abdul-Amir Osman says that صدای منقطع. Can you hear me? Is my voice clear? Okay. Let me repeat it again. While both distributed computing and parallel systems are widely available these days, the main difference between these two is that a parallel computing system consists of multiple processors that communicate with each other using a shared memory, whereas a distributed computing system contains multiple processors connected by a communication network. This is the main difference between these two types of systems. I want to say that they have both similarities and differences. They are similar in principles. What was the principle? We talked about it. Independent computing machines connected to each other through a network, and users can see the system as a one single coherent system. Here in these two systems, we have different independent machines or CPUs interconnected. Also, users think that they are working with a single system, so they have the same principle. However, in distributed systems, machines are connected through a network, and that is why in parallel computing, machines are usually, and not always, usually connected through a shared memory. And of course, in supercomputer, we have to use a network to connect racks and CPUs. So supercomputers also use a network to connect its processors. Moreover, there is a big difference about scalability. Do you know what is scalability? I said that there is a big difference about scalability in parallel computing and distributed computing. What is scalability? What do you think about it? Do not search on internet and copy paste it. Okay? Say me, what do you think about it? Have you heard it? Scalability? It's about a scale. System scalability. What does it mean? System scalability. Performance. Translate to Arabic. Scalability means مقیاس پذیری. مقیاس پذیری we say in Farsi. I don't know what do you say in Arabic about it. What you say مقیاس پذیری if قابلیت توزیع. Yes, so yeah. Yes, your definitions are correct. Scalability is the property of a system to handle a growing amount of work by adding resources to the system. I repeat it again. Scalability is the property of a system to handle a growing amount of work by adding resources to the system. In other words, a system is scalable if by adding the input, what I mean by input is about resources or about the problem, input problem. The performance of the system is not decreased. A system is scalable if by adding the input, the performance of the system is not decreased. Expandability is something different. Scalability and expandability are two different things. We can expand a system, but this system may be scalable or not. Okay, so no, it's not changes in a memory location. No. Future load, yeah. So I think the complete definition is that a system is scalable if by adding the input, by increasing the input, the performance of the system is not decreased. So keep in mind. We will learn more about scalability later, okay? So in parallel computing, the number of processors you can add is restricted. In parallel computing, in supercomputers, the number of processors that you can add is restricted, is limited. This is because the bus connecting the processors and the memory can handle a limited number of connections. It's about bus. It's about bus. You know what does it mean, bus? A way that in which data can transfer between different parts of the machine. It is bus. Yes, transfer information. Yes, it's for transferring information. Because our bus is limited, so the number of processors that we can add is limited too. There are limitations on the number of processors that the bus connecting them and the memory can handle in supercomputing. The limitation makes the parallel system less scalable. So this limitation makes the parallel systems less scalable. Distributed computing environments, on the other hand, are more scalable. This is because the computers are connected over the network and communicate by passing messages. So, distributed systems are more scalable compared to parallel systems. Got it? Good. I hope you take notes because these notes can help you to get the better mark at final exam. So be careful about these notes. In final exam, I may ask you what are differences and similarities between distributed computing and parallel computing. Please explain, and you should explain what are similarities and what are differences. What is the main difference? What about the scalability? You should compare these two systems together. Here, very good. Okay. So the next slide is about goals of distributed systems. Here you can see 4 main goals of distributed systems. If someone asks you, why do we use distributed systems and what are the goals, you can name these 4 items. The first goal is about making resources available. Making resources available. The second is distribution transparency. I will say you what is transparency. And also openness is another goal. Lastly, scalability. We talked about it and you know what is scalability. It is a goal in distributed systems. When I say that these are the goals, I mean that in distributed systems, we must try to satisfy these goals. We must prepare and provide these goals in distributed system. If a distributed system has these 4 goals, then it is a good distributed system. I know you don't know about openness and transparency or even availability. You know scalability, but however, I want to ask you, what do you think about these 4 goals? Which one is the most important goal in distributed system? Which one is the most important goal in distributed system? I mean, the most important thing that a distributed systems must provide, which one is? Transparency. All is important. All goals are important. Okay. But which one is the most important? Openness, the first, availability. If I ask you my question in other words, I say that which goal do you certainly expect that distributed systems must have? Which goal do you expect that distributed systems must certainly have? No. One student gave the correct answer. It's about availability. The main goal of distributed systems is availability. Resource availability is the main goal. When you are using a shared printer, so it must be available for you to easy to work with the printer. It must be available to you. Okay, it's called availability. Resources must be available in distributed systems. What are resources? What are resources in distributed system? Basic data? What do you mean by basic data? Computer, printer, etc. Yes, everything. Everything. A shared printer, computer, storage spaces, data, files, web pages, and network. These are resources. These are our resources in distributed system. So availability is the most important goal in distributed system. The resources are shared. I talked about it. We have limited resources and many requests. So we share and schedule to assign resources to users. For example, it's logical, I think. Imagine we have 4 or 5 employees in a room. In one room, we have 4 or 5 employees. What is logical and economic? Do you think if we buy a printer, a dedicated printer for each employee, or we buy only one printer and share it for all 4 or 5 employees? Which one is logical? Yes, yes, exactly. It's logical that we buy only one printer and share it as a shared resource for other employees. So it needs less money. It's sensible, it's logical, and it is a resource in the network. So if our system is a distributed system, it is very important that the printer must be available for all users. So availability is the most important goal. To reduce cost, yes, yes. and the money is very important in our world. But there is another problem. Imagine we share so many resources in the network, in the system for users. By sharing many resources, another concept, another important concept will appear. Can you guess? Can you guess it? What issue do I speaking about it? What issue do I speak about it? When you share many resources, as I said, it can be about files, data, information. When you share so many resources, we must care about, complete with a word, we must care about, interrupt, no. We must care about openness, no. ES? What is it, ES? Share many resources. In other words, I say that sharing many resources could have some problems. What's the main problem with sharing many resources? What's the main issue with sharing many resources in distributed system? It's about security. We must care about security. Why? Because we have a network and many resources are shared. Information, files, I don't know, storage spaces, hardwares, data, and the security is very important in this environment. Protecting users and information in this area is very important. Clear? Good. The second goal is about transparency. Transparency means شفافیت. It's Arabic, I know, and you can understand it completely. شفافیت, transparency. But what does it mean in distributed systems? A good distributed system is a system which is transparent, شفاف. What does it mean? Hide the process and resources. maybe, but I'm looking for a better answer. Can you remember the definition of distributed system again? The definition of distributed systems. Please tell me the definition. I want to explain by the definition. That is why I said it's very important to memorize it, this definition. Yes, a collection of independent computers that appears to its users as a single coherent system. Please pay attention to the last part of this definition. Users must see the system as a single coherent system. Okay? Must see the system as a single coherent system. It is transparency. It is transparency. We must try to provide some conditions that users see the system as a single coherent system. It is transparency. Yes, the system hides its distributed nature from its users. Exactly. And this is transparency. I mean, a distributed system that is able to present itself to users and application as if it were only a single computer system is said to be transparent. So, independent for each user. No. User must see a distributed system as a single system. It is called transparency. How can we make a distributed system transparent? How can we make a distributed system transparent? It has some techniques, some methods, some mechanisms, some principles. We will talk about it. So, the third goal is about openness. The third goal is about openness. What is openness? Right, that resource is replicated. No, openness. An open distributed system is a system The openness of a computer system, is the characteristic that determines whether the system can be extended in various ways. How it can be extended, the system can be extended. It is openness. The openness of distributed system is determined by the degree to which new resource sharing services can be added and be made available for use by a variety of client programs or users. So I repeat it again. The openness of distributed systems is determined by the degree to which new resource sharing services can be added and be made available for users. Resource sharing services we want to be added. If we can add new resource sharing services, our system is open. It is openness. What should we do? What should we do to provide the situation that we can resource sharing services, every resource sharing services in future? We must add some resource sharing services in future to our system. What should we do to provide an opportunity for this situation? Okay, we use network, but in network we must have some standard protocols. So by using these standard protocols, it is possible for us to add new resource sharing services in the future. Yes, if I want to clarify, let me give you an example. I'm thinking about a good example. Consider the internet, okay? World Wide Web, www, World Wide Web. This environment uses standard protocols. For example, for file transfer, if you want to upload a file, download a file, you must use standard protocols. Your application must use standard protocols. Programmers do programming and using a standard protocol for file transfer, FTP for example, and so on. So the World Wide Web develops and publishes standard protocols of the web. So it is easily possible for programmers to add new shared services on the web in their distributed system. For example, suppose that we are using a video conference and we don't have camera service, for example, in this application or in this distributed system. But it is possible to add this feature, this service in future, because there are some protocols that makes it possible to create some procedures and applications to use live video in our video conference, for example, by using standard protocols. It is about adding and extending services in distributed system. In simple say, I can say that openness is about adding and extending services in distributed system. By using interfaces, protocols, it would be possible. In other words, if a system can be extended, if a system is extensible, so it is an open system. How we can extend the system, or how we can add some services to extend a system? It needs some standard protocols. The extension may be at the hardware level by adding new computers, to the network, and at the software level by the introduction of new services. So extending is at two levels, hardware and software. At the hardware level by adding new computers to the network, and at the software level by adding new services to the system. Clear? Okay, good. For example, suppose we have a DMMS, distributed multimedia system. Our system is using Adobe Connect for this video conference. I am teaching to you and you are listening to me, okay? You can see the shared PDF and also you can chat with me. I can reply you. So if your friend, or if we want to add new student, it is easy. It can sign in into his account and it can participate in our class. So it is easy to add a new computer to our network. So our network, our system is open. The last one is about scalability. We talked about the scalability. What was the definition? What is a scalable system? I told you a few minutes ago, I told you. What is a scalable system? Yes, a system is scalable if it remains effective when there is a significant increase in the amount of resources. In resources and users, if we increase the input or resources, the performance is not decreased. In this system, we have scalability, or this system is a scalable system. 1. Now we want to talk about transparency in detail. We want to talk about transparency in detail. We said that transparency is a concept that makes a distributed system as a single coherent system. Users can see a distributed system as a single coherent system. It is transparency. But in detail, transparency in distributed system has different forms. You can see here the main forms of transparency in distributed system: access transparency, location transparency, migration transparency, relocation transparency, replication transparency, concurrency transparency, and failure transparency. The first is about access transparency. Access transparency hides differences in data representation and how a resource is accessed. Access transparency. Suppose we said, according to the definition, distributed system is a collection of independent computers. We talked about independent computers. I mean, each computer can have its hardware and its software, its operating system, its file system, a specific file system, a specific operating system. But these computers connected through a network. They are communicating. They are communicating. It means sending files between computer A and computer 2 is possible, even though computer A uses different operating system, uses different file system. But user cannot aware about this. It is access transparency. I mean, you can upload your files on Google OneDrive, okay? But which operating system and file system uses Google Drive? You don't know. It may be different from the one you are using. You are using Windows operating system. In Google server, Linux operating system, for example, is used. So there are different operating systems. There are different file systems. But you can use your files, upload and download from Google Drive, and you don't aware about it. It is access transparency. Got it? Was it clear? Good. The next form of transparency is about location. Hide where a resource is located. I think it's clear. Hide where a resource is located. For example, you use again your Google Drive account. So do you know where the server of storage of the Google is located? No, you don't know. Really, you don't know. Is it important to know? No, it's not important for you to understand where the server is located. It is location transparency. Hide where a resource is located. But how about migration transparency? Do you know what does it mean, migration? Migration means مهاجرت. Yes? تنقل. maybe مهاجرت is better word. انتقال. No, it's not انتقال. Migration, مهاجرت. Yes, مهاجرت. Hide that a resource may move to another location. You can move a resource to another location and users do not aware about it. For example, in Google, maybe servers are moved to another location. Will you be aware about it? No. It is migration transparency. When I say resources, it's not only about hardware. I gave you an example about moving servers. Okay, it's hardware, but resources may be, for example, shared data or software or application. So migration is about hide moving resources, hardware or software. The more stronger migration is relocation. Relocation transparency hides that a resource may be moved to another location while in use. While in use. Again, relocation transparency hides that a resource may be moved to another location while in use. While you are using a resource, it may move to another location. A good example is about using mobile phone when you are in a car or you are in a bus moving. When you are in a car and you are talking with your mobile phone, you may change your zone and the BTS mobile antennas may be changed, but you don't aware about it. It is relocation transparency. Clear? For example, you are using your laptop or your mobile internet in your car, okay? You are using your mobile internet in your car and your car is going to another location. You may change the main mobile antenna that you are getting service from, but you don't aware about it. It is relocation. While you are in use, you change the resource. So, are they clear? You can get completely, it's obvious for you. Access, location, migration, and relocation transparency. Very good. And the next form of transparency is about replication. Replication hides that a resource is replicated. What does it mean, replication? You have a very good word in Arabic for replication. Replication means taksir or takthir. No, tekrar no, takthir. Tekethere. Takthir. No, tekrar no. Do you know the meaning of تکثیر؟ تکاثر. تکفیر no. Yes, تکثیر. Mrs. Zahra, تکثیر. Okay? It's the meaning of replication. Yes, yes. تکثیر. Why do we use replication in distributed systems? Consider you are using online banking, okay? So your information and all data about your account are stored in some servers, okay? But if we store all the data in one single server, it is very, very dangerous, because if the server is crash, then we may lose data. Okay, so we use replication. We make some copies of data in different locations. We store copies of data in different locations. It is the meaning of replication or تکثیر. When we use different copies of data in different locations, if one server crashes, we can use to provide service for users still, okay, because we have another copy. Replication transparency hides that a resource is replicated. It means when you are using your online banking, you don't be aware about how many replication is there. You think that you are working only one system, not replicated data or systems or software and services. Clear? So it was about replication transparency. It means that you must not know that how many replication there are. And concurrency transparency. Concurrency transparency is another form of transparency in distributed system. It hides that a resource may be shared by several competitive users. Competitive users. Yes, it's about transactions usually. About transactions. As I said, we have limited resources, okay? But there are many requests. For example, in online banking, there is a main database who contains many different customers' information. Okay, many different customers' information are stored in this table. It's a database. At the same time, different users simultaneously want to access to this database. So there is concurrency. But concurrency transparency hides this fact from you. You don't be aware that different users are trying to access to this table or to this resource simultaneously. You don't know about it. It is concurrency transparency. Got it? Yes, yes, the definition is correct. When there is one shared resources or limited shared resources and you want to access it, your friend at the same time wants to access this resource, you don't be aware about it. You don't know. You think that you are the only person who wants to access to this resource. You think you are the only person who access this resource. It is concurrency transparency. And the last one is about failure transparency. Failure means خرابی. Failure means خرابی. Okay? Or yeah, fashion or fashion, I don't know. Or we say شکست. Hide the failure and recovery of a resource in distributed system. Failure transparency, hide the failure and recovery of a resource. For example, you are using I don't know. I'm looking for a good example for failure transparency. You are using a resource, okay, and the resource maybe fails, okay, the resource may fails. You must not be aware of it. You must not aware of it. And the resource after a few milliseconds recovers, and you can continue getting your services from the resource. You must not be aware of failure of resources. It is failure transparency. You don't have a failure. The resource fails. The resource fails, not you. You are using a resource in distributed system and it may fail. You will not be aware about it. Failure transparency in distributed system is really difficult to implement. It is really difficult to implement, to provide some conditions that makes a system as a failure transparent. That is why because it's very difficult to distinguish between a slow system and failed system in distributed system. You know what am I saying? It is very difficult to distinguish between a slow system and a failed system, because you are using network. For example, you want to transfer money, okay, and when you click on transfer, you are waiting and you must wait, okay. If the resource is slow, you must wait. If the resource fails, also you must wait. So it's difficult to distinguish between a failed system and a slow system. So failure transparency is difficult in distributed system. Yes, should be hidden. It must be hidden. As I said, it's very difficult to distinguish between a dead resource and a slow resource. It's difficult to distinguish. Why a system or resource may fail? Why? Why? I mean, what is the cause of the failure? What is the cause of the failure? Let. What is the cause of failure? It is because of faults. Fault. Do you know what is it? Fault. 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 Here. In Arabic, it means إشكال. إشكال. Fault or إشكال. Flat, no. Fault. Fault. إشكال. For example, in network, we may have some noise, okay, in area. We may have some noise, and this noise would be a fault for our network. So the network may fails. Okay. Okay. So we talked about transparency. In the next session, we continue our discussion about degree of transparency. How much transparency would be useful in our distributed system? It's about degree of transparency. We will talk about it next session. Okay. So, how was this class? How was this session? Okay, you're welcome. Oh, I told you about PDF. Please wait. Please wait. And once I finish chapter 1, I will upload it. Okay? So you must be patient. Please wait. Where are you now? Where are you now? I mean, is there any student who lives in Karbala or Najaf? Very good, very good. Please do prayer for me if you go to Haram. Please do prayer for me. I'm very interested in traveling to Karbala and Najaf, but unfortunately, due to COVID problems, it's impossible for me. And so you can do prayer for me. التماس دعا. Okay, thank you. Have a good night and خدا حافظ.